So let's start with the session on data analysis using R Studio. So today we are going to discuss the concept of, first we'll discuss the concept of correlation, and then followed by we'll discuss the concept of regression, right? So let's talk about what is the concept of correlation, why we use correlation in research, what is the importance of correlation, then how to interpret the value of correlation, that we are going to discuss in today's session, right? So when we talk about correlation, means it is talking something called as relationship, right? Correlation means it's talking something about the relationship between the variables, right? So when we say relationship, means we are talking about not about single variable, we are talking about the relationship between two or more than two variable, that is called as correlation, right? Whether there is any correlation between two or more variable or not. Okay, so let's talk about first correlation meaning, or we can say the definition. What exactly is correlation? So the correlation means the relationship. It talks about the relationship and between the variables. Okay, it talks about the relationship between the variables, right? It's not only talk about the relationship, it also talks about what is the strength of relationship, right? We say what is the strength of relationship, whether the strength, when we say it is a positive strength or whether it's a negatively okay, that's how we decided based on our variables, right? So another feature of correlation is it gives the direction. It gives the direction and the strength. Okay, strength of a linear relationship. Linear relationship. So, linear relationship between the two or more variables, right? It deals with the direction and it also deals with the strength of the relationship between the two or more variable. That is nothing but your correlation, right? Now, two things we should understand here. One is something called as standardized term, okay, and one is something called as non-standardized, right? Non-standardized term. Now, first try to understand what this concept is, standardized and non-standardized. So when we say standardized, right? Standardized means it has some range, okay? It has some kind of a range, or we can say there is something called as testing is possible in case of standardized. Testing is possible in case of standardized. And in case of non-standardized, it does not have any kind of range. Okay? It does not have any kind of range. Okay. So it is just a value. It is just representing some value, which is not having any kind of specific, we can say the value, or we can say specific to the range, right? And second thing is we cannot do any kind of testing here. When I say testing is possible and not possible is we are talking sometime, for example, in terms of your p values you can take, or you can take in the form of any kind of significant levels, whether it is that possible or not, that we can do. So that's meaning of testing here. So it means it's difficult. It is difficult for testing the values. So let's say, for example, So usually what happens when we say non-standardized, first we'll discuss non-standardized, okay, standardized, this term, non-standardized term. So how do we say that particular concept is non-standardized? Suppose, for example, there is we have one example of non-standardized is something called covariance, right? So when we say covariance, which is a non-standardized term, which does not have any kind of range. So what is covariance? It's a variance between the two variables, right? So covariance is nothing but variance between the two variable. So when we say covariance, so it means you should know that we are finding the covariance between the x and y, right? So x is your independent and y is your dependent. So covariance is nothing but it's nothing but the value of x and y, right? So usually we calculate covariance like this. Okay, we can say covariance is equal to correlation into, right, standard deviation of x into, okay, standard deviation of, we can write it here as x into standard deviation of y, right? So it's a standard deviation of y. That's what we say covariance, right? So if this particular covariance will calculate, okay, it's nothing but it will only signifies the variables variance between the variable. What is the variance, right? So when we say covariance, no, it can be any values. It doesn't come any in the form of range here. So for example, if you talk about, let's take one example I'll discuss here. Okay. So you have something called as sales here and you have something called as profit here, right? These are the two variable you have, right? So let's imagine there is a sale of 2000, 4000, okay, and then followed by you have sales of around 10,000. Profit is, okay, around 800, okay, and then you have around 1000. It goes on, and then you can say there is something called as 1600. So this is, let's assume, first year, second, third, fourth, fifth. Okay. Now, if I want to just see to that whether is there any possibilities of between these two, I can calculate what is the covariance, right? So I can say simply as covariance of dot s. Okay, covariance of s. So this is my first variable, okay, covariance, and this is my second variable, which is your profit. So between these two, what is the covariance? Okay, I think we have to select dot S here. So covariance between the this one, let's once again covariance. Okay, we'll take it this one covariance dot S. So this one and this value, that is your profit and your sales, between these two, what is the covariance? So there is a high value. You can see the covariance is around more than 10 lakhs, right? But this is too extreme, right? This value of which we got 10 lakh rupees or 10 lakh, right? That's a covariance between sales and profit. That's too high. It's extreme value. But when we say this particular value, which is not under any kind of range, there is no specific range. So for when I say range means, is there any minimum, any maximum? Nothing like this. There is no minimum and maximum in case of covariance, right? But if I say, for example, if you do something called as correlation, okay, which we called as covariance, next part is nothing but correlation. So if I just want to check the correlation, so I can do the correlation, like for example, I can take correl here function is equal to, and I can take it this as my first variable and this is my second variable. So if I do this particular calculation, so I'll get something called as correlation 1. So it means this one is a positive. Now it means there is a something called as 100% relationship is there between sales and profit, right? So look at the difference between covariance and correlation. So when we say covariance, which doesn't have any kind of range specifically, but there is a range is available in case of correlation. So it means what? When we talk about standardized and non-standardized term, right? So it means we need to understand that the standardized term is nothing but your correlation, and non-standardized term is nothing but your covariance, right? So we say non-standardized, okay, standardized example, we can write it here. It is my correlation, and here non-standardized term example, we can write it as covariance. So this is very important to understand. So why we say that is standardized and non-standardized? Because when we talk about correlation, it has some kind of a range here specifically, right? So its correlation is nothing but we take the particularly covariance, right, between the x and y, and then we take the standard deviation of both the variable x and y here, right? So let's talk about now what is correlation here, then we'll proceed with the further. So this is standardized term. Okay, let me write it here as standardized term. That is, we previously discussed what is non-standardized, right? This was non-standardized, which is covariance. Then let's discuss now standardized, right? So we know that in standardized, there is something called as range of variables, right? So there is specific range between lowest to highest something called, or there is some kind of range is available. So what is the example of standardized? We have something called as one correlation. So let's talk about what basically correlations, how it is called as standardized. So for example, I'll take it here. So this is just a one line which is specifying your range. So I told you there is a possibilities of what range in case of correlation, right? So this is line where there is a one endpoint and another endpoint is there. This is just take at -1, okay, and this is your 0, and this is your +1, okay. So it means there is your correlation value can be either between of this, either it can be -1, or it can be 0, or it can be +1, right? So for example, if I want to uh, get the value, means the value will be lies between this only, right? So there are two things. One is -1. We say this is nothing but 100% negative correlation. So we can say perfectly negative correlation. And when we say +1, means this is a perfectly positive correlation, which is nothing but strong correlation, right? So we can say this is negative correlation, but perfectly strong negative correlation, right? So is there any specific, we talk about any, we say whether this value has, what value we should consider with to decide whether it's a strong or weak. Usually what we do in correlation, if the values goes, okay, beyond just let's say 0.85 or 0.75 and above 0.8, anything value goes, we say that value is perfectly strong correlation. Okay, this is called perfectly strong correlation in the variable, right? So we have something called weak correlation also. Weak correlation is if the value is suppose less than 0.75 and all, if anything comes below this value and all, or we say there is a weak correlation in the independent variables, right? So we have, when we do analysis, we'll get to know whether it's a strong or we say weak correlation based on our data results, right? So this is what we have in front of us to understand positive and negative correlations. Okay. So your correlation can be positive or your correlation can be negative, which is called a standardized term, right? So let's go to this one data set in our studio, and we'll work on this one, and let's decide whether there is a possibilities of getting correlation values or not. Okay. So can you see the data R studio, everyone?
Yes, sir.
Yeah. So let's talk about, please open your R studio and then we can run some analysis over here. Once you're ready, please let me know. You can raise your hand if you're ready with. so that we can work on this particular uh, data set. Okay, Vibha is Nitya is ready. Fine. What about Arun? Janvi, are you ready? Hello? Yeah, fine. Perfect. So I think all of you are ready. So let's go and do the analysis of correlation. So first, what we'll do, we'll have a data set with us. We'll take today different data set for our understanding over here. So let us type here correlation. Okay. We'll take the data set here. There is a data set called as orange. Hmm. Control enter. Just press it. Control enter. So let's talk about this data set. Orange, what does it mean? Okay, orange, just you get it's a growth of trees. So just all of you try to understand what is this data set talks about and what is the importance of this data set. So this data set orange, which talks about the description, which has 35 rows. This is a description and three columns. So when we say three columns, these are three variables. Okay. Then you can see the what exactly these particularly columns are telling. Okay, you can just see here. Tree, that means it has order factor indicating the tree on which the measurement is made. The ordering is according to the increasing maximum diameter. Okay, so you can see here the first tree which has age of 118 and which has the circumference of 30 and followed by it has increasing the diameter with 1, 2, 3 and 4 and 5, right? Then age, what does this age represent here? It's a numeric vector giving the age of the tree. Days since 1968, okay, 31st December 1968. So when we say the age means they are talking about age in the form of it's a number of age we can see from that particular day, okay, from this till the latest, okay, what is the age of that particular tree. Then you can see circumference, which talks about a numeric vector of trunk circumference, that is mm. This is probably a circumference at breast height, a standard measurement in forestry. So that's a total circumference of that particular tree. That's information they have given for all the type of tree. There are almost 35s are there. And then this data set was originally a part of the package NLME, and then it has a method including AS.frame, plot, and print we can use. What is the source of this particular data from where we got this? This was written in 1998 by this paper, Applied Regression Analysis, in one of the textbook. They have taken this particularly and they have mentioned that this particular data set. So that's a source, and you can see there are few example you can they have given how do you plot and how do you run this particular analysis in the R for your example. So you can just if you copy this code and paste it and run, you can get this, okay, analysis. So for this to do you require stats package and you require some graphic package. So that's what they have given over here. So let's go on and do the correlation for us to understand what basically. Okay. So after that, please run this code install.package called as lattice lattice. Okay. Just it's a one kind of a package which talks about the graphic, which is help us to do some kind of graphics. So just press Control Enter and then it will ask you want to install restart R. So just I'll take it yes and I'll keep it here, this particular package. So let it get installed, install.package. Okay, once it is done, I think it's ready now. We can just take it library and then we can type lattice, this particular library. So I hope it is ready now, and then we can just run the code now. Just type it here. Splume. Okay, Splume is one kind of a function which is under lattice package we have got. Just type Slume and open the bracket and just take the okay. Before that we'll run this code called as attach orange. Okay, just type it here, attach orange, control enter. Then you can type this code as Slume. Okay, Splume. Okay, open the bracket and here you can type it as orange, that is your data set, and just press control enter here over. So you will get some kind of a graphical representation of this particular data here, right? So you can zoom and just check it. What is the importance of this particular graph? You can just check it. Okay, so you have a scatter plot, which is matrix. This is a scatter plot matrix, which is giving the information about the tree and the age and the circumference. So this is how the data is being distributed over here in the form of different observations over here, right? Everyone got this one output?
Yes, sir.
Okay, now let's work on the another one. Okay, so just go on to the next one. Now let's see what is the correlation we can do here. So just type it here. Let's imagine I want to check the correlation between, okay, correlation between the age and circumference. Okay, circumference. So we can write it this one as, let's imagine I want to test the what is the correlation between the age and circumference. So let's do it that one. So before that, I just want to understand whether the how do we frame the hypothesis for correlation here. Okay, hypothesis for correlation testing. So when we talk about hypothesis, we'll talk about null and you have something called as alternative hypothesis, right? So let's see what basically null represent and what basically alternate represent over here. So you have two variable in front of you. Those two variables are, one is your age and one is your circumference. Okay, circumference. So now let's frame the null hypothesis. Now we are testing the whether there is a correlation or not. Since by correlation value we can get whether there is a relation, whether it's a strong or whether it's a weak correlation. But we need to test for by taking something called as hypothesis. So let's imagine I'm framing null hypothesis. So null is like a negative statement. I'm saying that there is no, okay, there is no correlation, or let me write here, there is no relationship. Since these are two variables, there is no relationship between the age and circumference. Okay, circumference. This is my null statement. Okay, so let's do the alternative statement. What is alternative? Alternative is look like a positive statement where we talk about where there is a relationship is there or not. So can you just anybody help me in framing alternative statement for this? So I'm saying null is there is no relationship between the age and circumference, right? So can you just help me in making what will be the alternative statement for this? What can be
There is
alternative?
relationship between age and circumference.
Yeah, yeah, perfect. So we can say there is a relationship between age and circumference, right? So this is my alternative hypothesis, circumference. So now we need to remember we should accept or reject this null and alternative. So how do we decide whether we should accept the null or reject the alternative? Based on which value we have to take something called as what? probability value, right? This is called as p-value. So what is the threshold limit? If it is more than 5%, okay, if the p-value is more than 5%, so we can say there is, we can say accept the more than 5%, accept the null, and we can say reject the alternative, right? So once again, if it is less than 5%, we what we can say accept the alternative, and we can write it here as reject the null hypothesis, right? Reject the null, accept the alternatives. Clear? Am I clear with the hypothesis statement?
Yes, sir.
Yes, sir.
Okay. Now let's go to the R and just we'll test this whether it what kind of value we'll get it over here. So let's go to here and just type core, that is a correlation, okay, between the age. Uh, you have to take age, the first age, press comma, and then you have something called circumference. Okay, just press Control Enter and you will get the value. So can you tell me what is the value you got? Did you got the same value?
Yes, sir.
Nitya, Janvi, Arun.
Yes, sir.
Okay, so now what is the correlation value? Let me copy and paste it here in the Excel. So between the age and circumference, okay, correlation value is correlation value, how much we got? Is it 0.91? So now let's try to understand what is this 0.91. So how do we interpret this value of 0.91? First of all, you tell me whether 0.91 is a positive or negative value,
Positive.
Positive.
right? It's a positive value. So it means there is a positive relationship between age and circumference. Am I clear?
Yes, sir.
So what we can say, the strength of association between age and circumference is 0.91, means as the age increases, might be the circumference also will change of that particular trees. So that is 0.91. Now the question is whether I'll give you two options. You have to tell me whether it's a weak or strong correlation.
Strong.
So it is a strong correlation, we can say, between the age and strong. Perfectly, we can say it's a strong, perfectly positive correlation. Perfectly strong correlation, or you can say perfectly positive correlation, right? Positive correlation. Am I clear with this concept of this,
Yes, sir.
right? So now the question here is, okay, we got to know between this age and circumference, there is a positive correlation. But this particular correlation, how do we connect with our hypothesis? That is very important here. How do we decide whether there is a relationship is there or not? So it means we require something called as p-value, right? So this p-value will tell you whether there is a relationship is there or not, right? So for that we need to go to the R and let's find out the next test code here, code dot test. Let's do this one, and then again we'll define as my age and circumference, right? So let's do this particularly and type the code over here, and let's get the output. I think you got the Pearson product moment correlation. So this is correlation dot test. So if you see here, this particular value over here, okay, first let me check whether you got or not, everyone. Did you got this value?
Yes, sir, got it.
Got it, sir.
Right, perfect. So now when we talk about this particular correlation between age and circumference, you can see here, okay, from this particular data, there is something called as p-value. Can you see here this particular? Okay, so let me just copy and paste it in my Excel. So let me write it here, my p-value. So I'll just copy and paste here. So my p-value is this particular value. Okay, and just I'll take this one, 1.91 E14. Okay, what does it mean? This one, E means exponential to the 1 4, right? That's 14x. So I'll just convert this into proper number format cell, and just I'll go to number and I'll keep it decimal as 5 digit, and just I'll change it this value. It becomes 00. So my p value is, okay, almost equal to how much? 0.000, right? This is my p-value of age and circumference. Now you tell me this p-value, I'll just highlight from here, and then we'll decide this particular p-value, whether it is more than 5% or less than 5%.
Less than 5%.
It is less than 5%, right? Yes or no? So this p-value, I'll write it here, which is less than 5%. So whenever we have p-value which is less than 5%, p means your probability value, what we should do? We have two here. Which one we should accept and which one we should reject here?
We should accept the alternative and we should reject null.
Yeah, so we should accept the alternative and reject the null, right? So what is my alternative from this particular hypothesis statement? Can you please just tell me what is your alternative? What is alternative statement? There is a,
There is a relationship between age and circumference.
yeah, so there is a relationship between the age and circumference. Am I clear?
Yes, sir.
Right? So this is what we got from the p-value, right? Then one more thing, if you just go down and if you just see here, can you see COR value? Can you look at here on the screen? COR. What is COR here?
Correlation.
So here the correlation value is 0.91351. So did we got the same value here also? Right?
Yes.
So it means this is my correlation value between age and circumference. Okay. So now can you just check the correlation between tree and circumference? In fact, that is not correct. I mean, cannot say, but still, can you just try for doing the correlation between tree and circumference? Just all of you can just try and check it. What is the value you are getting of correlation? Just take between.
Sir, I'm getting X must be a numerical variant.
Okay, so there is some chances. It's not possible, right? Because when we talk about here this particular value, if you see the range of it has some kind of 1 1 1 and 2 3 4 and 5, right? So if you see, and this particular circumference is having some kind of deviation, so there is a lot of deviation between this, right? So what did you do? You type the code core dot test bracket open tree comma circumference, right?
Yes, sir.
So you will not get the value because it's not possible to calculate the correlation between the tree and the circumference. But between age and circumference, definitely you can find out the correlation, right? So that's how we need to understand over here the correlation between the values. Okay. Let me do another way. Let's do the another type of doing the correlation. You can just run this package called install.package. You can run this code him HMISC, just that's called Harald miscellaneous. Okay, that's the one package you can install in your system. Okay, and let's find out how to get the correlation between X and Y in the form of diagonal. Right, so let's run this code. After that, you have to install the package. After that, you have to do immediately library HMISC. Just you select this one. H should be capital. Control Enter. Okay, and then you can just run this code RCORR. Okay, so which is comes from your Harrell miscellaneous package. Open the bracket. Age, comma, you can type circumference over here, and just you can get the value of correlation from here. That is, if you see here this particular correlation, so I think you will get here X and Y. I hope you got this value like this. Are you getting everyone?
Yes, sir. Got it, sir.
Yeah, so it means X and X, there is a always positive, perfectly strong correlation, but X and Y, there is 0.91, and the same value we got over here also, that is 0.91, right? Here also we have 0.91. Clear?
Yes, sir. Got it.
Now let's do it for another type of data set. We had empty cars over there, and let's find out between this what is basically the correlation between that. Okay, so just run this code library pscy psych. Okay, just press Control Enter, and then after that you can just type attach. Okay, and then type empty cars. Control Enter, and then you can run this code data is equal to empty cars. Okay, let's do it on this particular comma 3 is to 8. Control Enter, and then you can just run this cor dot ci, open the bracket, and then type the vector name as data. Okay, and you will get the graph on your right side of the screen. So the graph is like this. I hope you can just zoom and check. So you will get the graph correlation, which is one kind of a graphical represent between the values over here. All of you got this one?
Yes, sir.
Got it, sir.
Got it. Okay, what about others? Nitya? Okay. So how do you read this value? Once again, we can say DISP, this is, remember we had some variable DISP, and DISP there is a 1. So it's always between X and X, the relationship is always 100%. So DISP and HP, there is a 0.79, that is 0.79, which is a positive correlation, but between DISP and DRT, there is a negative correlation. Weight and DISP, there is a positive correlation and followed by negative correlation. This is called as correlation graph, or we can say plot. Okay, which is one kind of a plot we can use for our research papers, and you can use for your report preparation also, right? So again, we can do one more plot by installing one package called as install.package called as core plot. Okay, just we can run this code where we get different package graphical representation of the correlation. Okay, so that also we can do it. So let it get installed, and then you can do library, okay, of this particular package called as core plot. Just type this core plot. Control Enter. Okay, so that is library core plot. So then after that, you can just let's run the mtcar dataset correlation plot. I'll give you vector name something called as m core. I'm putting here, okay, and bracket open, and then I'm typing here mtcars. Okay, and then after that, I'm just putting here the head variables, okay, of the first file. Open the bracket, then you can say round, okay, then m, but here m will take it as the capital M, comma 2. Then let's run this and check what is the correlation. I think we got a uh, matrix kind of correlation between the variables. Okay, just see here. Did you got this correlation? You can see there is a 1, 1, 1 diagonal in the form. So that is between the correlation, and MPG's correlation is 1 always. MPG and CLY, the correlation is minus 0.85 and followed by this another two variables over there. Got it, everyone? So you can see there are many positive, many negative correlations are available that from that particular graph here, right?
Yes, sir.
Next one, let's see whether how we can do with the statistical value in terms of R. Okay, let's do it. We can install another package. Okay, just type here install.package and type ppcor. This is one package you have to install. ppcor. Okay, this is you have to install. Control Enter. Just press and just install this package called ppcor. Then what you have to do, once it is installed, you can do the library for this particular package. Library ppcor, you can just take it here, Control Enter, right? Then after that, let's run this code. Okay, we'll create new vector called as data is equal to data dot frame. Okay, and we'll take few variable from mtcar, mpg, we'll take hp, and remember weight. These three variable we'll take, and then we'll press Control Enter. Okay, after that we'll just take ppcor, that's a package where we taken, and then you can take it as pcor. Okay, that's called probability of, it also shows p-value and statistical value over here separately. And then just take the data of these three variable mpg, hp, and weight, and press Control Enter. So I think you will get the result over here. And just look at this result here, how we have got here. So this is a estimate and this is a p-value, and you can see these are all correlation value, and these are all statistical terms of t statistics value over here. And these are all what we say the correlation value between the variables. So these are estimates, p-value. So since the p-value in majority of the case, you can see there is something called as e. So this is exponential value. If you just convert that into proper decimal value, you will get that is equivalent to zero only, point some 00, but you will get that is almost equal to zero only. That's p-value. Then you can see the in all the cases, in this case, this is your probability value. In all the cases, you can say there is we are accepting the alternative hypothesis and we are rejecting the null hypothesis over here, right? Clear? Did you got it? Are you able to get it, everyone? Okay. What about others?
Got it, sir.
Janvi,
Got it, sir.
right? So Very important, we plotted how the correlation graph and all it is done. That's what we discussed from this particular session over here related to your correlation. Okay. So now let's go on to the next concept of let's do it something on regression, and then we can see how the regression is used in particularly in R studio. We'll discuss that one concept next now. So let me go to the Excel sheet over here. Now let's talk
Sir,
about, yeah, hello.
sir, I have got only two outputs, sir, of HPs and WT. Only two outputs I got, sir. MPG is not defined, it's showing, sir.
Okay, what you can do here, you can attach this code, you run this code 78. Just click here and just click run.
Okay, sir.
Okay, you will get the output. Right? Shall we proceed?
Yes, sir.
Okay. So let's move on to the next topic. Let's discuss the concept of regression analysis. When we talk about regression analysis, let's see what exactly is the regression is used for and what is the importance of statistics over here. So when we talk about statistics, we have two important categories of statistics as we discussed already in the beginning session, that we have something called as descriptive statistics and you have something called as inferential statistics, right? So we have covered descriptive statistics in the beginning part. You have something called as inferential statistics. So under inferential statistics, what do you mean by inferential statistics? We are trying to infer, okay, infer the population, okay, we are inferring inference population, okay, from the sample result. So basically what we are trying to say here, whatever the result which is given by the sample, it is representation of the population, right? So that's why it is inferential. It is inferring the entire population of the data, whatever we have collected. So it means the sample result, we don't do statistical analysis on population. We take the sample from the population, right? So we say sample is a subset of population. So based on the sample, we take the statistical analysis and that sample statistics result will represent the entire population, right? So that's the objective. So what are the tests we use under inferential statistics? Okay. So we say type of test under inferential statistics. So under inferential statistics, we have, as we discussed in the last class, we have something called Z test. We have something called T test. Then you have something called ANOVA. Then you have something called MANOVA. Okay. Then you have something called as correlation. Okay. Then you have something called as regression. Right? So all this, there are many statistical tests are available, which are part of inferential statistics. So all these tests are covered under your inferential statistics. Basically, this regression is also one type of inferential statistics, okay, which defines the entire population, what exactly the sample, the result is given, right? So a regression, basically, this is a technique which is used to study two or more quantitative independent variables. When we say independent variable means we talk about the explanatory variable also, right? So let's talk about two things, okay? So regression is one kind of a technique which we study the effect of. So in regression, what we do in regression, okay, we study the effect of two quantitative variables, or we can say two quantitative independent effect of two or more. It can be two or more than quantitative independent variable. Okay, right here on dependent variable, right? So basically in regression, what we do, we study the effect of independent variable on dependent variable, right? So let's assume from this particular equation, as we discussing yesterday, y is a function of x variable, and then we say y is your dependent variable and x is your dependent variable. So we write it here. So y is dependent variable, okay, and x is your, as usual, independent variable. Okay, independent. So we say that what is the impact of x on y, right? So if x changes, y will also change. So that is nothing but y is changing because of x is changing, right? So we say y is your dependent variable, okay, and x is your independent variable. So many times what happens, the there is a always change because of x, and there is a always effect is available on y. So this is cause variable and this is effect variable. So we can say x is my cause variable and this is called as effect variable. So basically what happens, if there is something happened in x, it will change the y's. Okay. So when we say regression, our objective is to determine the values of parameters that cause the best fit to a set of given observations, right? So what is our objective of doing regression? We are trying to study the best, we can say best cause that fit the model, right? So we can write this equation like this also, y is equal to a plus b into x also. That is also one equation of writing the parameter. So here we know y and x are dependent and independent. Then, but there are two things. One is a and one is b here. So what is a here? A is called as here alpha, or we say this is called as intercept value. And then you have something called as b. B is called as beta, or we can say this is also called as your slope value, right, in statistics. So remember these both a and b, right? This a and b are constant over here. So I'll just write it here. A and b are my constant variable. Then only what is changing here, the only factor what is changing from that one is your x and y, right? So we can say that, let me select this one up. Yeah. So what is constant here? A and B are constant and X is your not constant, right? So this is when we say A is equal to B, A plus B into X, we called as SLR. This is also called as simple linear regression, right? Simple linear regression, right? Then if I say, for example, from your variable, okay, and if I add few more variable from this is, let me write it here, eqn1, equation number 1. Okay, so let me write one more equation, that is equation number 2. Okay, so when I say equation number 2, I am writing like this: y is equal to a plus, okay, b into x1. I'll write it here, x1, plus again I'm writing here b into, okay, the b is your beta value over here, that is your x2, okay, plus b into, I'll write it here, x3, and it will go on like this. So now what is happening from this equation, we can say here, So in this equation, we can see that this particular variable which is has x1, x2 and x3, right? So when we say x1, x2 and x3, those are independent variable. So now what is constant here? What we say constant here? The constant is alpha and those beta parameter of each independent variable. Okay, so those are constant values. So this, when we have one y but multiple x, this is called as MLR, right? We called as multiple linear regression. Okay, this is your multiple linear regression, right? So now, what is simple linear regression and multiple linear regression? We are talking about when we have y and x, and when we have multiple x and y, which differentiate the between your y and x, which is defined as simple and multiple linear regression. Yeah. Clear? Got it, everyone? Hello?
Yes, sir.
Yes, sir.
Okay, right. Now let's go to the R and let's do the analysis of some data set, and then when I'll tell you the interpretation there only, what are the values are coming there, okay? So let's go to the R studio, all of you. Let's come to here and let's run the equation. Well, let's run about multiple linear regression, or we can say regression. So let me write here regression analysis. Okay. So I am going to do directly multiple linear regression because there is no point of using simple linear regression. I'll take the empty car dataset as my base for doing this regression analysis. Okay, so multiple regression analysis, I'll write it here. Please type this one, everyone, so that we can work on this particular data set. Multiple regression analysis. Now let's define here as since I told you in the last class, I think somewhere we were discussing here in the in my one of my session, I told you that we had discussed what is your dependent and what is your independent. Okay, so I hope this is that information. So you remember MPG is the variable which is called as your dependent variable, and remaining all other are called as independent variable. I hope you remember this one. MPG is miles per gallon, which is your dependent variable. This is your DV. I'll highlight this one, and this is my IV over here, right?
Yes, sir.
So now let's do it on this parameter. I'll just go to R and just I'll run this. Okay, so just type this code attach empty cars. Let's work on this one, and then finally we'll develop one. We'll create something called as model one. I am taking over here as one of the vector, and then okay. Before that, I let me tell you what are the packages are required. Install dot packages. You required lm over here. Okay, just type. Okay, you can just type is equal to double inverted lm package. Okay, and then you just press Control Enter, and then you can do library lm. You can just type it here. You will get this linear model. Okay, I think we have not installed. It's getting installed. The package called as lm linear model. Lm stands for linear model. Okay. So let me just go. If I think if it is not coming here, you can go to tools and just click on install package, and here you can type lm test. Okay, you can just see here there is a package. You can go to tools and just you can type lm test. Okay, or you can just run it here only, lm test. Now I think it should run lm test. Now it is getting installed. Okay, once it is done, you can just do the library. You can run this code lm test that is used for regression model over here, right? Clear? Did you got it? This package, have you people installed?
Yes, sir.
Nitya, Janvi.
Yes, sir.
So now let's work on this one and we'll type it here. Model one. I'm creating a new vector called as model one less than. Then you can type it as lm, open the bracket, and then you have mpg. Okay, I'm just taking mpg is my dependent variable. That's why we should always write first as dependent variable. Then you can type disp. Okay, then you keep on adding the variable cyl. Okay, disp over cyl. Okay, then plus you can type here mpg. Then you have hp. Then you can click as drat. Then you can click plus wt, plus you have qsec, that is your one of the independent variable. Then you can type as carb. Okay, all these are your independent variable which is defined under this model, right? Press Control Enter, and then you can just type model one which is created over here, and then you can just see the result of this particular variable coefficient values. You got it here. So these are all your coefficient values from that particular data set. Okay, this is your intercept value, which is nothing but your alpha value. I told you this is your intercept value. Just let me go down and just show you here. Okay, this is your alpha, which is called as intercept value. So we got intercept value as 26.15955, and then followed by you have DASP, and these are coefficient value, that's called slope value of that particular parameters. And then if you just run the next code summary of this particular model, okay, SVMAR summary. Okay, just type summary and just bracket open model one. You just run, no, you will get this all this value, which is nothing but regression value. You will get it over here, very important result here. So you can just see here, this is lm formula, which is mpg is dependent on disp, cyl, hp, drat, weight and q6, and then followed by coefficient. This is your intercept value, this is your standard error t value, and this t statistic value, and p value, that's called probability value of that particular data. And then you can see over here all these are all your independent variable, and then you can see one of the variable has star mark over here. Can you see this star mark over here? Are you getting the output, everyone?
Yes, sir.
What about other? You got it? Yeah, perfect. So now let's try to understand what does it mean of this star. So first what we'll do, let me come back to Excel sheet and just I'll write it here. Hypothesis testing of regression. Okay. Basically, we should first frame the hypothesis, then we can run the regression. First, we'll do the null. I'll write it as H naught. H naught is called as null hypothesis. there is no impact of, okay, independent variable on, okay, independent variable on dependent variable. There is no impact of independent variable, okay. So there is no impact of independent variable on dependent variable. So what is your dependent and what is your independent? That is, we have defined here as independents are all, these are independent variable, DISP and these all are called independent variable, and MPG, which is this one. So I'll just take it this copy and paste it here so that it will be easy for us to understand this particular concept. So our H1 will be like this. There is a impact of hypothesis. There is a impact of independent variable on dependent variable. Okay. So among all this, you can see here, this is how the equation will come. And among all these things, I think weight has the significance value of weight is equal to. So can you see this is called p value? Okay, the weight p value is how much? 0.0261. Okay, I'll just take it from here and just I'll take it, copy paste. Okay, so I'll just go to R and I'll copy the significance value, which is having 1 star. So that means this particular value of weight, which is nothing but significant, but other than that, there is no value which is coming significant. So it means that weight p value is, this is your p value, okay. Significance value is also called as p value. So which is 0.0261. So we can say, which is once again less than how much percent? 5%. So if we have to accept the alternative hypothesis, so our alternative hypothesis says there is an impact of weight. We can say one of the variable called as weight on mileage per gallon. But if you see here, other than that, there is no variable which is having impact because all are above 5% only. All are above 5% except weight. So remember, weight will have always impact on mileage, right? As the weight of the vehicle increases, the mileage goes on decreasing. If the weight is less, the mileage will increase. So this means there is a direct relationship between weight and mileage. Clear?
Yes, sir.
Okay, then you can see you have something called as here R adjusted R square value, and you have something called multiple R value, which is called as correlation value also. And this is your model P value. And then you can see the overall F statistic value is also 20.19 and degree of freedom is 24. Okay, and your R square value is also good here, which is almost, we can say, 0.81 only. It is near to that value only at R square, right? Then if you just go to R and let's see, plot the, okay, and just run this particular code now. Okay, and let me run this one. Yeah, just push it up a little bit. Run this code number 97 and let's check the coefficient value. If you want to check, you can just type coefficient and then type model 1. You can just see all the coefficient value, you will get it over here, right? If you want to check the confidence interval value, you can just type confint, okay, and then you can type here model 1. You can just check the confidence interval value also here. This is at 2.5%, at 97.5%. Those are all your confidence interval values over here, right? At the same time, you also can check the fitted values. Okay, we can type it here fitted values, which are called as predicted values. So, what are the predicted values of this particular model one? So, let me just write fitted bracket open model one. So, these are all your predicted values of your dependent variables. So, this is predicted till this is your mileage per gallon, as I told you, MPG. For all this, it has calculated the forecasted value, and then you can compare this forecasted value with your actual value. The difference is nothing but your error, basically. So we got this model. So this is basically nothing but what is the use of this? These are all called as predicted values over here. Okay, this is the objective is to predict the values. So those are predicted values, and you also can predict the residuals, which are called as the errors. So you can just type residuals and then bracket open model one. So and just press okay, you can write it here. This is all about your residuals in the model. So we called as error in the model. So what are those errors? We can also get those values. So just you can press Control Enter, and you can check here what are my residuals, which are first residual is 1.36, which is minus. So how do we calculate this residual? Is basically actual value minus forecasted values. Clear? Are you getting these values, everyone?
Got it, sir.
Yes, sir.
So let's do it now. If you want to check what is the ANOVA of this, you can just type ANOVA model one, and then you can press Control 1. So you can check here the responses of analysis of variance is called as ANOVA table. Then you can see this all the values of ANOVAs. And again, you can see from there you got weight as significant at 2 star, which is called as at 10%, and followed by you can see one more significant CYL, right? Then this is your analysis of variance table, which is nothing but compared between the two means of different groups. Then you can also build something called variance covariance matrix of this. You can just type model one from this one and just press Control Enter. You will get this is called your variance covariance matrix. So you can just write it here. That is called covariance matrix, right? Is it clear? Got it, everyone?
Yes,
Yeah,
sir.
perfect. So let's go on to the next one, and we'll type the next code as let's do the graphical representation of the residual. Okay, we can say residual diagnostic. So par bracket you can write mfro. Okay, mfro is equal to c comma 2 comma 2, and just let's see what is the graphical representation of this. You can just type as plot, and then you can type this as model one, and you can see okay, I think here we have got some graph which is I'll just run once again this one, and I think figure margin is too large. It is showing. Okay. So I'll just reduce the size, but you should have got this graph by running this code. Are you getting everyone graph like this? Now I think it
Got
is
it, sir.
showing. So these are residual versus fitted, and this is your normal QQ plot. Remember, it is used for to understand the distribution of the data, and is a scale location graph. Fitted values how far it is closing to the range of the line, and this is your residual and versus leverage, which is one statistical model. We have something called Cook distance, which is used to understand the residual diagnostic values between the leverage and actual values. And then you can just run the next code. Okay, I hope this one is got everyone. Am I clear with everyone?
Yes, sir.
Yes, sir.
Okay, so that's all about your regression over here. And let's talk about the next concept in this. I have to tell you a few things about the interpretation of the model over here. How do you interpret the values? So let me come back to my Excel sheet and then you can write it here. Interpretation of the inter interpretation of R square value of regression. So I'll just write it as R square, which is very close to adjusted R square only. So I'll just write it as R square SQUAR, R square value. Let me go here and just take it. What is my R square value? I'll just go up and you can just see here. So this was my, yeah. So my R square is 0 point, which is nothing but I'll take it this as my value for my analysis as a R square value. I'll just copy here that value, which is 0 point. I'll go here and just paste it here since that is adjusted R square, but there's slightly difference between R square and adjusted R square. I'll just tell you what first let's assume this is my R square value. So what is this R square value here represent, which is if I convert this into percentage, okay, and I'll just take these values here and then I'll just take it into percentage once again. So let's try to understand what this value means. I'll increase to percentage. So it means what do you mean by this R square, which is 81.25? So when we talk about this particular value of R square, it means that there is a, okay, what does it, 0.81 or 81.25%? It tells that 81.25 percentage of variation in Y is explained by X variables. So it means what? It means that Y is changing, Y is changing 81.25 percentage because of X variables. There are multiple X, no? So X is changing Y, but Y is changing because of X. How much percentage of Y is changing because of X? That is 81.25 percentage. Then the question here is out of 100%, right? Out of 100%, 81 percentage is changing, means we left with 100 minus 81.25, we left with around, and just convert this value. Okay, so I'll take it here, this as 100. I'll not put it percentage here. Take it normal values number. This also I'll write it here as value 81.25. This is also normal value only for me. 81.25. So it means that how much is the balance? 100 minus this value. So you can say this is values. I'll convert this into number. So around 18.75. Okay, I'll just keep it this one. Yeah. So this out of 100 percentage, Y is changing because of X only 81.25 percentage, means remaining 18.75 is not changing. So this is nothing but there are some unexplained factors are there. We call as this is unexplained factor. There are unexplained factor means, or we can say there are some unknown variables are there which are changing the Y. That is how much percent? 18.75 percentage. Y is changing because of some unknown factor. We don't know what is those unknown factor. That is called as random variable. This is random factor. Those are random factor we called as ET. ET is your error. Okay, those are some unknown factor which are changing the Y value, but that is not explained in the model. That is called unexplained model factors, which is changing the Y. That is why it is called as error. So there is an error of 18.75, and but the model is good. It is around 81.25. So it is a good model, we can say, is because since R square is good over here, right? So that's the meaning of your R square value over here. It means your Y is changing because of X. So that is 81.25. The percentage of variation is Y is explained by X is 81.25. What is not explained, that is called 18.75, which is error. Am I clear with this, everyone? Then understood? Let's go to, okay, now that was all about your regression. Okay, now let's discuss the next concept of time series analysis. Right? So let's do it in R. What exactly the time series analysis? So here we'll talk about in time series analysis, something called as stock analysis. So let's do it. Okay. Please come to this R and then you can just type it here as time series analysis. We'll do it here by with the help of R, and let's try to find out which time series analysis we'll do it. Okay. Here you have to do couple of packages. You have to install that install.package called as uint conf mode. Please run this package. Okay, then after that you have to do something called as the library. Okay, and then you run this code called conf mode. Okay, then you have to do one more package. You have to install dot package called as xts. Okay, this package you have to install. Then you have to do library. Okay, then you can do xts. Then you have to install one more package called as rwest. Okay, and then you have to do library for this particular package rwest. Okay, so I'm giving you here, these are the package. You just please run this code from 106 onwards. Just write it here. Then you have to run this package called as install dot packages called PID tidyverse. Okay, this one you have to install. Then you have to do, after installing every package, you have to do library. Then you have to do tidyverse. Okay, so enter. Then install dot package. Okay, stringr stringer. Then you have to press Control Enter. Okay, just you have to install that one. If it is asking restart, you just do it that one. Then you have to do the package called library strngr stinger. Okay, and then you have to do one more package. Around there are 10 to 11 package you have to install here. Install dot package called as for ca for cats. Okay, so yeah, for cats. You have to take this package install. Then library you have to do, and then type for cats, which is used for categorical variables if you have the data set. Then you have to install dot package called as lub lubridate. This is one package you have to install. Then you have to do library. Okay, lub lubridate. This is one package. Then install dot package plotly plotly. And then you have to do library plotly ly. Just run this package. Then I think we have installed this package called pplyr. Then you have to do library dplyr. Then what we can do here, last package is install dot package called as performance analytics. And then you can run the library for this performance analytics. Okay, so you have to run all these packages before we proceed. I have just, I'll share in the chat box all this package and their code. Just copy And I think I'll just share with you all this package in the chat box. Okay. So I hope you can see here. It will just take some time, but it is only one time installation. Okay. So once it is done, then we can go ahead for our analysis. Clear? Please let me know once you finish. Raise your hand.
Done, sir.
What about others? I hope you have installed. Okay, 2 people have installed. 3, 5. Right. So let's run the code and we'll do some basic time series analysis. Just type start. Yes, dot date. D is capital and just we'll take in the bracket double quote 2000. Let's say I'm just taking one range start date of the any stock 0101. It's 1/1/2016 is my start date. Yeah, I'll just press Control Enter. Okay. Then at the same time, for every stock, you will have a start date and end date. Just type N is dot date. You can take it here as N dot 2008. Then you will take it 2016. I'll take it till 10/2001. Okay, just I'm putting some October 2016. This is my end date. Okay, then after that, let's do the next code get symbol. Okay, get symbols. You can just select from here, open the bracket. I'm taking one stock called as APL, that is your Apple stock. Then press comma. I'm taking source is equal to I'm taking from Yahoo. Okay, that is your website, which we can take it from there, comma from. And when I'm selecting from is equal to, we'll take it as a start and then press comma from to is equal to as end. Okay, that is your. So we have already defined what is start and what is end. Just press Control Enter. You will get the symbol called APL. I hope you got this one like this. Yes. Done. Got it, everyone? Hello?
Sir, I'm getting the could not find function get to null.
Oh, not find function getter. Oh, okay. S is capital there.
Yes, sir, it is capital.
Yeah, symbol bracket AAPL SRC Yahoo. Okay. What about others? Did you got AAPL down? Apple, that's a stock name. How about others? Okay. Might be the previous what we can do. One of the package must have not installed properly. I think it has come like this. Just run this code after that head. You can type APL and you will get control enter and you can see here you will get the Apple open, high, Apple low and close price of that from first. You will get some first few days of that particular stock price. 4, 5, 6, 7, 8, 9, 10, 11 till first 11th of January you will get the price of Apple including the volume and what is the adjusted closing price of that stock. At the same time you can just type tail open the bracket APL, you can just run this. You will get the stock price of bottom that is from 30th September till that, but it starts from 23rd of September till 30th. That's the bottom you will get here, right?
Sir, I think that we have this, I think, and then as object AAPL not found.
Yeah, because might be your this code is not run properly. So we just I'll share
Yes,
this
sir, I
code.
didn't get that.
You have to run the code this one once again.
Sir, even I am getting the same errors.
Might be your package has not got installed properly, one of any of the package. I have shared the code in the group. You can just run with that. Done.
The function get to null.
Yeah. So I think you have to do this rerun library cont mode. You have to run the package library once again. Then you will get that one. Okay. Library cont mode. You have to run then that one. Right. So let's go to the next one. What about Nitya? Did you got it?
Sir, my R, like it was installing packages and it's crashed or something. It's still downloading.
Yeah, yeah. In between, it will ask whether you want to restart or your pack, or you just click yes there and you just run once again.
Okay, sir.
I got it now.
Okay, okay, right. Then I'll just show you here plot APL, okay, and then we'll run plot the graph of Apple stock. Press
Sir, I
comma.
got the code got executed, sir, but I did not get the output, sir.
Okay, no problem. We just run the next code. APL dot, you just run this code APL dot close. Okay, come out of this bracket, then put comma main is equal to, you can run APL. Okay, and just if you can margin is too large, it is showing. I'll just reduce the margin of the size of this particular screen. So, and I'll rerun the code, and I think you will get the graph like this. Okay,
Yes, sir, got it.
you will get the graph. Okay, if I zoom this one, I hope so you will get this graph in different manner, right? Am I clear? Okay, I just okay. So let's move on to the next one. We'll plot the next type of chart. Just type candle chart. Open the bracket APL. That's the stock name. Then you up.col. Up.col is nothing but if it is a the stock is up, it will show you some color. So we'll give it define the color as black. Up dot color is black. Press comma. Then you can if the stock price is going down, we'll put it TN dot con color is equal to I'll put it as red. Then comma. Then you can write it here. Theme is equal to white. Okay, theme will keep it as white. That you can keep it outside of this and just you can run this code. Okay. And then I think again it's showing figure margin is too large. So what I will do now, I'll just keep it small margin so that you will get the graph over here and candle chart APL comma up color and DN is simple black and then red. I'll just run this one. So there is some error. Let me check what is the error here. Theme is equal to white. Okay. Dorsey layer number of rows and number of columns. Okay. What about this one? Okay, fine. This is the graph I got. Color DN. You got this one? Okay, I think we'll get
Yes.
now. Yeah.
That one only, sir, I got.
This is your candle chart basically. How do you get forth? So wherever you have black, that is up, and wherever red is there, that's a down. So up is nothing but price is rising. So it means the closing price is higher than the opening price, and down is red is nothing but opening price is higher and closing price is lower. That's the meaning of their down. That's a candle chart over here, right?
Sir, I got completely in black, sir.
Okay, so just check the code. You can see the visualization over here, right? Got it, everyone?
Yes, sir.
Okay, so let's do it one kind of a multiple chart. I'll just zoom this one. I'll run the next one. Let's do it multiple chart. Get symbol again. That same code I'm running here. Get symbol. Open the bracket. C. Since C is used for multiple, then I'll take it two charts over here. One is okay. I'll just take it Microsoft, that company. MSFT, I'll type it here. Then I'll take it here, comma. Then one more company, I'll take GOG. Okay, just type GOG. Then comma, you can press SRC source. I'll take it from Yahoo. Okay, just double inverted, press comma, and then from is equal to start, that is already defined over here, and then press comma 2 is equal to end. This is my end, 2 and start, and just press Control Enter. You will get Microsoft and Google. Then what we can do here, you can just type it here, next code called as stocks. Okay, just let's do the next code stock. Okay, we'll define the vector as stock as dot xts, that is already coming. I just zoom a little bit and just show you here. Ax dot xts, open the bracket, then you can type data dot frame. Okay, and then you can open the bracket. AAPL apple is it should be repeated as apple only. So AAPL is equal to apple. Then you can just open the bracket. Okay, press comma. We'll take it apple closing price will display over there. Okay, then another stock will take it as MSFT. Again, I will represent as MSFT. That is Microsoft is equal to Microsoft. Then open the bracket. Same way you should write for Microsoft also, comma, double inverted MSFT dot closing price. We'll take it that one. Okay. Then one more stock I'll take it here, that is GOG, that is Google is equal to GOG. Okay, again open the bracket, then press comma, then GOG dot closing price, we'll take it for that stock, then close the bracket, then 2 times bracket you have to close, Control Enter. Okay, I'll just share this code, you please run. Okay, it's difficult little bit in the chat box. Just run this. You can copy and paste this code. Okay, now what we need to do is we have already defined the code and the stocks over here. Now let's plot the graph for all the three stock, Apple, Microsoft, and Google. Just type plot as.zoo. Okay, that's one package we are going to use. Take the stocks that is already we have taken. Okay, open the bracket, close the bracket, stocks, comma, screens is equal to 1, comma, LTY, okay, is equal to 1 is to 3. Then press comma, then X should be labeled as date, we'll type it as date, and then Y will be labeled as YLAB, lab is equal to, we'll call this as price. Okay, Y will be labeled as price. Then I think I'll just minimize my screen, okay, so that the graph will come on without any troubling up for us. So I'll just press Control Enter. Okay, LTY. Yeah, there is some error here. Okay, sorry, we have put here minus, but it's not minus. It is LTY is equal to 1 is to 3. I think now we should get the graph. Okay, so I think we got the graph here like this. So this is a three stocks. Remember Apple, Microsoft, and Google stock price. So I'll just share you this code. You can just run from the chat box. You can just copy and run this code. Clear? Now I'll just put it legend for this particular graph. Okay, because to understand simplicity. So legend will keep it in right. Okay, then press comma C, open the bracket, APL. Okay, that is the first stock. Then second one is MSFT, then MSFT, comma, then GOG, Google, right? That's a stock. We have three stocks and we have graph. and LTY is equal to 1:3 we are defining. Then text size will take it as 0.5, and then I think we can run this. I think we'll got the legend on the right side. Okay, so we'll just copy and we can just paste. I'll share this code. Please run this code from the chat box and you can get it here how exactly this is the graph. So you can see this line is your Apple stock, that is your first stock. Then MSFT is your dotted one, okay, the high dotted one, this is your MSFT. And Google is the lesser dot, the space between first and second dot is very less, that's your Google stock. So how the stock is go, this is your Apple, the last one from bottom first, okay, then this is your Google, and then followed by your Microsoft. This is your stocks, right? Everyone got it, everyone? So this is how we do the plotting of graph and candle charts of your time series data, which is your stock price data over here, right? So we have completed here the session on basics, descriptive and time series part. You can use this code for any of the stock, whichever you want. Just instead of Apple, you can give any of the different stock name. You will get the data for that particular stock. And please do understand, you can define the start date and end date. According to that, the information will be captured by the R from Yahoo source, and you can see different graph you will get from the based on the availability of data over here, right? So I'll just stop it here. Thank you.